Okay, so we'll get started. The first thing I wanted to do was to look at your exam schedules to set up office hours. And so I went through this morning. The X's are when there are exams, and therefore no point in setting up office hours. So right now, according to the morning group, Monday afternoon would be fine. No exams on Tuesday, exam Wednesday morning, exam Thursday PM, nothing on Friday. And I know Monday you have this exam. So I've already circled it Monday morning of the exam day. So we'll have office hours. Are there any exam slots that I'm missing? So anywhere that you see a check mark, is there an issue that you have an exam? Just put your hand up, let me know. Now, I can't guarantee which ones I'm going to get because there are exams being written in 302 and there are other people with office hours. So I'm going to, based on this, see what I can get. Any questions about that? Or other questions? Okay, so Wednesday, actually, I'll post on course link, but Wednesday, we'll indicate when the office hours are for next week. Oops, didn't do that correctly. All right, yeah. So plan is to go through an old exam, and at the rate we went through it this morning, that may be what we get done this week, but that's okay. My original goal was to have it taken up by Wednesday, and then Friday was and whatever you want to go through. So having said that, whether we get through all of that I'd like with this exam or not, if you have particular topics that you'd like to discuss on Friday, send me an email. So I can at the very least, even if one at a time, say, okay, here I wrote this solution, which goes through this, or whatever it is best. So please do that. All right, so let's get started. This was a deferred exam from winter 2020. And I've now looked at this question and solved it 3 different ways. A mass and spring undergoes simple harmonic motion. Its vertical position is given by the equation x of t is equal to 0.2 meters times sine bracket 2 pi t minus pi over 2. It is pulled down 0.2 meters from equilibrium and it is released from rest. When will it first have maximum downward acceleration after it is released? Up is positive. So the solution that I'm going to post, because after we go through this, I'm going to post the solution for all of these questions, involves recognizing the relationship between position and acceleration. So if you have a spring and a mass, and you pull it down, at this point, you've got maximum extension, and when you let it go, you're going to get maximum upwards acceleration because it's going from 0 to something. That's a big change. That's a big, and I already said it all. And that acceleration will go to 0 when it passes through equilibrium. And then it will begin to slow down, which is the next acceleration down. And that will be maximum or most negative when it gets to the highest position. So when I did it the first time, I just said, okay, I'm going to set x to t to be 0.2, that's what I do. And I'm going to solve for time. And that works. And then another way of looking at it, which we did this morning, is recognizing that to get acceleration, I just have to take the second derivative. And so that's just going to be equal to, so I have to use the chain rule. So I get 2 pi each time I do the derivative. So first to find x at t. The first time you take the derivative, you get, we start with sine, you get cosine. And then the second time you take the derivative, cosine is negative sine. So you get minus 0.2 times sine 2 pi t minus pi over 2. Okay? And we want to know when that is a maximum negative value. Well, all of this is the magnitude. So the maximum it can have is minus 2 pi squared times 0.2, and that will occur when 2 pi t minus pi over 2 is equal to pi over 2, right? Sine of 1. That's the biggest you can get, is 1. So from that, you get 2 pi t is equal to pi, because you get pi over 2, bring it over the negative pi over 2, that gives you pi. So you get t is equal to 0.5 seconds. Questions about that? Yes, okay. Yeah, in fact, that's what I said I did at my first solution. That's what I'm going to put. And then when I was walking back from lecture this morning, I went, hang on a second. There's an easier approach. Not that these are terrible, but so again, come back to the situation. We're pulling it down, we let it go. It goes up through equilibrium, up to maximum, back to equilibrium, back down to minimum. That's a cycle. That's half a cycle. Half a cycle is half a period. So if I define the period and divide it by 2, I've got it. So this is method 2 or 3. So omega is equal to 2 pi, which is equal to 2 pi times f. Therefore, f is 1 hertz. Therefore, t is 1 second. Therefore, little t is 0.5 seconds. There's often more than one way of doing these problems. And a helpful thing to always remember, whether you have a pendulum or a mass on a spring, it always completes 4 amplitudes per cycle. So the pendulum, right here, 1 amplitude, 2 amplitude, 3 amplitude, 4 amplitude. Spring, 1 amplitude, 2 amplitude, 3 amplitude, 4. Questions about that? Okay, moving on to the second one. How many maxima will be found in a 2-source interference pattern? In the bright region of a 2-source interference pattern when produced when a blue laser illuminates 2 slits that are separated by 0.5 millimeters if each slit is 75 micrometers wide. You remember the other day when we did this last Wednesday? Oh, here it is. So when you have two slits, what you really have is two diffraction patterns which overlap and interfere with each other. So you get the bright central maxima, and then you get the secondary maxima, and then maybe the third, whatever. So this is the diffraction pattern. And within that diffraction pattern, you get interference maxima. Now, I'm just drawing in just to give you a picture of what's going on. You always get m equals 0 in the middle. And what we want to know is what is the biggest value m can have. The m is 4. It's not going to be 4. And so so you get to the exam and you knew you were going to get one of these questions, but you're panicked and you're not sure what to do. You run out of time. You left this one and you're coming back to it. And that's exactly 1 minute left. And so you look at it and you go, okay, I don't know what to do, but I do know that there's always m equals 0 in the middle, and then the same number in the right, which means there always has to be an odd number. Always. When you're talking about interference maxima, there will always be an odd number. So that eliminates the union. Not doing anything to think about that. And sometimes that's what you need to do when you get to a question. So don't give up. Yes, it still leaves you 3, but that's better than 5. And then you may be able to conclude pretty quickly that 7 is way too few. But let's go through the solution. So what we have in the question is this right here is n equals 1. That's the first node for the diffraction. And on the other side, it'd also be n equals 1. And so this is theta 1. So that theta 1 must also contain all of our maxima. So we know that sine theta n is n lambda over w. So sine theta 1 is lambda over w. So we know that. We know lambda and we know w. So we know that. But I'm going to show you that you don't actually need to calculate it. You don't need to find theta 1. You can, perfectly correct. You don't need to. Theta 1 must contain theta m, which is the angular position of the maxima. So we're going to set sine theta 1 to be equal to sine theta m, which is equal to m lambda over d. So when you do that, you get lambda over w is m lambda over d. You can see that the wavelength actually didn't need to be given. And so m is just d over w. And d was 0.5 millimeters. So that's 5 times 10 to the 5 nanometers. And W I don't know why I'm doing it in nanometers. Anyway, and then it's 7.5 times 10 to the 4 nanometers. And when you do that, you get 6.67. Therefore, M, you always round down, is 6. You get 6 on one side, 6 on the other, 1 in the middle, total 13. Questions? Yes. So I didn't actually bother. I could have. So basically, we found sine theta 1, which is the location of the node. And within that angle, all of my maximum has to be that. So I said, within that angle, what's the maximum value of the maximum that? And so in this case, sine theta 1, I said sine theta 1 to be sine theta 10, which is really what I'm doing, because I said theta 1 to be theta 10. If the two angles are the same, and the two sines are the same. And so if one did actually occur at theta 1, then it would be the 6.67 maximum. You can't get a decimal maximum. All you get when you do. The angle is not big enough for it to be the 7. It does contain the 6. That, no? Other questions? Okay. Now, with this question, I think the vast majority of the students, when they wrote it, went straight to the calculation without thinking about their answer. It says a student is measuring the speed of sound using a tape measure and a stopwatch. The student and her friend stand 105 plus or minus 2 meters from the ball court. Her friend claps her hands and she measures the time for the sound to echo off the wall. That's to be 0.61 plus or minus 0.02 seconds. What value does she get for the speed of the sound? And I want you to think about the answer without getting hung up on the uncertainty. The uncertainty, we're going to go through the uncertainty. It's very mechanical. Most people did not make a mistake on the uncertainty. What they made a mistake on was something a little bit more physics. When you look at those answers, you should be able to, based on reason, eliminate them without doing any uncertainty. You can see that basically there's really two values there. Uncertainty is over. That's not what we want to make a mistake. You see anything that kind of eliminates answers logically? Okay, so that's actually using the physics to rule something out. But that was great. But fundamentally, you did a lab on the speed of sound, and you had to compare it to what you got way off. But, and on your formula, you know the speed of sound is 340 meters per second, not 170. I don't think that, maybe if you were in a room full of sulfur hexafluoride, then, well, you've got big problems, but then the speed of sound might be that. But there, speed of sound varies slightly in temperature. It could be higher than 350 or 330, but it's never 1 second. And the most popular answer was B, I believe. Okay, so now let's deal with the problem. So the problem is we want to find speed, which is just distance over time. So the distance is just 105 plus or minus 2 plus 105 plus or minus 2, which is equal to 210 plus or minus the square root of 2 squared plus 2 squared. Right, when you add and subtract, you square the absolutes. So it's 210 meters plus or minus 2.82 meters. Okay. So now we have 210 plus or minus 2.82 divided by 0.61 plus or minus 0.02 seconds. Now we're doing division. So now we have to work with relative errors. So when you do this division, you get 344 meter per second plus or minus. Now you add the relative errors in quadrature. Questions so far? So you get 344. Now this is a relative error. So this is, if I wanted to put it in percent, I'd multiply by 100, but I don't. So when you do all of this, I believe you get 0.035. And notice I'm not writing units down because it's relative. So when you do that, the goal is always to express it in terms of absolute. So I just need to take 3.5% of 344. And when you do that, you get 12. Okay. Now, based on that, there's really only one outlet. Has to be E, but just to convince yourself. So we must write this to just one digit. So that's the tens. Okay? This is also the tens. So this is 3.4 plus or minus 0.1 times 10 to the 2. One digit, and it's in the tens. This is in the tens. They always have to be the same. Questions about that? Yes. How did I get control from one? Sorry, is that the question? How did I get control from one? Yep. And then how did I get one? Oh, you're 1.035. It's the relative. Relative variance is that 3.5% there. With 3.5% is equal to 4. Other question? All right, next one. So, it says, consider the force diagram below. The forces are in equilibrium. The force FB only acts in the YZ plane. The force FA only acts in the XY plane. The force FC acts in the positive x-axis. A 575 Newton force acts in the negative Z direction. What is the magnitude of the force FC? Right? So I'm going to begin with my goal. My goal is FC. The only force acting in the X direction is FA. FB is completely in the YZ direction, and the 575 is completely in the Z direction. The only force that's in the X direction is FAX. That's it. So if I knew FA, I'd be done. But I don't. So you can see I've got a direction triangle, 30, 40, 50, or 3, 4, 5, it doesn't matter. So of that 50, we can see that 30 centimeters are in the X direction, and 50 centimeters is the hypotenuse. So I'm just going to write that as 3/5 times FA. You can get the angle and you can take the X and Y components, cosine and sine, you get the same answer. 3/5 of that is in the X direction. Okay, so if I can get FA, I can get FC. So now I'm going to try and solve for FA. So if I look at my picture, FA has an X and a Y. The only other one that has a Y is FB. Sorry. Okay. Start on the right-hand side, go back to A. So we got 4 centimeters, or 40 and 50, so it's 4/5. And if we look over at FB, we can see that it's 3/5. So FA is equal to 4/5 FB. So if we can get FB, we've got FA. Once we've got FA, we've got our goal. So now we can finally use the 575. FBZ has to equal 575. It's a 75. Okay. And so you can see that 4/5 of FB is equal to 575. So FB is 5 times 575 over 4. Any questions so far? Yes. It's what fraction of the FA is the hypotenuse. So in the X, that's 3/5 of that vector. And in the Y, that's 4/5 of that vector. And if you want to think of it in terms of sine and cosine, and we're looking at this angle right here, then you can see that this would be the adjacent side, which would be 4. Hypotenuse would be 5. This would be the opposite side, which would be sine, and there's the 3, and again 5. That makes sense, huh? Okay. Okay, so I can replace, there's something wrong here. This one, I feel like there's a math error somewhere. So FC is equal to 3/5. Okay, that's correct. FBY is equal to FAY. And that's 3/5. Ah, there it is. I knew there was a mistake. You see right here? I got 3/5 and I got 4/5. So these divide out. And so FA is equal to 3/4. I knew there was something wrong there. Right, just divide 3 by 4 and you get FA by itself. So now I substitute into here and I get FA is equal to 3/4 times by 5 times by 575, all divided by 4, which is 15/16 times 575, which is 539. Okay. Now we have one last step to do. FC was 3/5 FA. Which I believe is the 3 point. Someone check that for me. whatever that answer was. C. Questions about that? So these, all these things. The sum of the forces in the x was 0. That's kind of our starting point. That's where we had our x. The sum of the forces in the y was 0. The sum of the forces in the z was 0. And so we had 3 equations, 3 unknowns. And we used them to solve for, the only one we cared about in this case was FC. Okay, so expect to see some variation on this theme on the exam. Other questions before we move on? Okay, this one's a little easier. Person is standing at a concert 50 meters from the speaker. They find the sound intensity of the sound too loud and they walk the distance of 100 meters. I never go to the front of any concert. My hearing is bad enough, I don't want to make it worse. But I'm quite excited. For the first time in 2 years, I'm going to a concert on Saturday night, so that would be nice. Okay. 50 meters from the speaker, they move to 100. I want to know what the difference is. So what I want to know is beta 1 minus beta 2. And I've done beta 1 minus beta 2 because I know beta 1 is bigger. If you did it the other way around, you just get the same answer, but a negative sign. And it only asks you what the difference is, so it doesn't make any difference. So it's just 10 log I1 over I0 minus 10 log I2 over I0. So using your rules for logarithms, we can replace that subtraction with a division. It just becomes log I1 over I0, all divided by I2 over I0. And when you do division of fractions, it's like multiplication of the reciprocal. So you can see the I0s divide out, and you're just left with 10 log I1 over I2. Now, some people will just look at this and say, oh, it's 1 over R squared. I started off with 50 times 100. That's a factor of 4 drop in intensity. And then you're done. But you can also recognize that I is just power over area. The simplest one of the two is the sphere. So that's just 4 pi times R1 squared. I2 is just equal to P over A2. And power doesn't change, that's the source, that's the speaker. Whoops. And so you can see that when you take the ratio of that, you just end up with R2 squared over R1 squared, which is 4. I2 divided 4 pi is dividing 1 over R squared, R1 squared divided by 1 over R2 squared. And then that's it. 10 log 4 which is about 6. One of the two. Questions about that one? Yeah. So which of the following does not have the characteristic of an electromagnetic wave? So all of those wavelengths and all of those frequencies are by themselves characteristics of an electromagnetic wave. I can tell you things that have frequencies of each of those, right? The radio wave 102.1 megahertz, that's a radio wave. Gigahertz, that's if you have a phone, a landline at home, communicate with gigahertz. So those are all realistic. The question is, do they produce a speed which is consistent with electromagnetic? So you can actually, if you look at it fairly quickly, you got 10 to the 16 for the last one. And 10 to the minus 6 is the microwave. So you can see that that one is faster than light. And if you don't see it, that's okay. You cut it and you'll see it. So for the first one, we got 555 times 10 to the minus 9 times by 5.4 times 10 to the 14. And when you go ahead and work that out, you get 2.99 something times 10 to the 8 meter per second. So that's consistent. We're really trying to see, is there anything else that's not? So the next one, we've got 2.936 times by 102.1 times 10 to the 6. And again, when you do that, you get 2.99 times 10 to the 8. And then the next one, we got 28.55 times 10 to the minus 3 times 10.5 times 10 to the 9. And when you do that again, you get 2.99 times 10 to the 8. So all three of those are valid. The other one, the last one, is greater than the speed of light. So it cannot be good. Questions about that one? Yeah. You should know this, but it'll be the basic one. You know, million micro minus 6, nano negative 9. That's going to go smaller than that. And then the same ones in the other direction. Kilo, you know, 10 to the 3. Mega, 10 to the 6. Giga, 10 to the 1. So 3 is 6. Another 6 you're really solid on two already below a million. Those really micro, nano, giga, and mega. And if you want, as soon as you get into the exam and you're told to go, write those on your formula sheet. Just like write any other additional formulas along. All right, so I think we have time for one more. Now, here's where understanding will really help you get the answer rather than just getting hung up on the math. So we know the object is placed 10 centimeters away from the line. And the difficult length to work with is the converging length. Because where you put the object determines the unit. If you put it outside the focus, then you get a real inverted image. And as you get closer and closer to the focus, that image will get bigger and bigger and bigger and bigger until you get focus. At which point, there's no image. And then inside the focus, that's not like that. And now you know, I'll point a magnifying glass to the bigger and up, right? But if you got a diverging lens, they're boring. They do the same thing every time. It's always smaller, upright, nice. No matter where you put the object, always. So the reason I say this is this question looks like it could be fairly time consuming. Lensmaker's equation. R1 is negative. R2 is positive. You got minus minus. P is less than 1. Diverging. So always, the only one is E. Right? You can never get a real image from a diverging line. So those are all gone. And they never make things bigger. They make them smaller. So that's what I said. If you understand what these things are doing, as opposed to getting hung up on the math, you can get to the answer much faster. But you can use this equation, figure out the power, and then substitute in power is equal to 1 over 0.1 plus 1 over di. Find di. You're going to get that it's negative. And then find the ratio of di over do. You can see it's less than 1. And you'll get a upright, smaller, imaginary. But that's extra step. So if you can get this there, great, do it. Questions about that? Okay, I don't think, I won't rush to try and get through the next one. We'll start with that on Wednesday. Okay, I'll stick around. You have questions? Otherwise, enjoy your day.